L, M, and N are the vertices of triangle LMN. Part A, find the length of MN, correct to 1 decimal place. B, calculate the gradient of Ln. C, if P has coordinates negative 26, 19, show that L and P are collinear. D, determine the equation of line MN. And E, show that triangle LMN is right angled. Let's start with part A. Find the length of MN. To do this, we can use the distance formula. The question tells us to find the answer correct to 1 decimal place, so we need to use our calculator. But before we do this, let's look at exactly what we're working with. Let's say that M is our first point and N is our second. So we can say the distance of MN is equal to 3 minus negative 3, close the bracket, squared, plus negative 2 minus negative 6, close the bracket, squared, all under a square root. Now, before we put these values into our calculator, let's simplify the brackets. 3 plus 3 gives us 6, so we have 6 squared, plus negative 2 plus 6 is 4, so we get 4 squared, all under a square root. Now we can take our calculator and we say square root of 6 squared plus 4 squared is equal to, let's change this to decimals, and we get 7,2111. The question tells us to find the length of MN to 1 decimal place. So let's round off. We get an answer of 7,2. Now we can move on to part B. Calculate the gradient of Ln. We need to find the gradient of the line between L and N. So we can use the gradient formula. Let's say that L is our first point and N is our second. Now we can say M, the gradient of Ln, is equal to 3 minus negative 1 over negative 2 minus 4. 3 plus 1 gives us 4 over negative 2 minus 4, which is negative 6. 4 and 6 are both divisible by 2, and we get 2 over negative 3. And now we can move on to part C. If P has coordinates negative 26 and 19, show that L and P are collinear. From our previous videos, we know that if points are collinear, they lie on the same line and they have the same gradient between them. We have just found the gradient of Ln to be negative 2 over 3. So let's make a note of this over here. To prove that L and P are collinear, we need to show the line LP or the line NP has the same gradient as Ln. We are going to look at the gradient between L and P, but you can use either. Again, let's use the gradient formula.